So today, the ds-incubator is the first in a series of 2. The idea is to discuss tools that we can use to create plots. And the goal should be to give an overview of the ones that some of us are more familiar with, so that you can decide which tool might be useful for one or another situation. The focus of today will be Gplot 2, and then next week Pranav will extend this meetup with some tools that he is familiar with. But overall, beyond showing some of the tools, we would like to kind of discuss as well. So I would like to start actually this meeting today with a preliminary discussion. Maybe I would encourage Claire to be the first kind of explaining what's the motivation behind this series of 2 meetups, and then opening also the room for everyone else to kind of comment on which tools you use right now. It could be anything from, say, Excel to, I don't know, JavaScript or whatever. And also what challenges you face when it comes to plotting data. So Claire, could you give us a little introduction about how we came to these meetups?
Great, thanks Maro, and thanks for pushing us forward to organize this. Yeah, so I think this is an important discussion to have and fairly critical as CJ and Pranav both move on from the organization, and we're sort of left with a bit of a gap. You know, we've tried to take our technical prowess on this a little bit further forward, but yeah, this has been led by sort of experts rather than everyone working on this. I mean, everyone does work on this, but yeah, without sort of a cohesive message there. So the primary thing that's motivating me to talk about this is that I think it would be a great time to have a bit more clarity on what everyone's opinions are on creating a more standardized solution for plotting in the future. So I think there's a few elements to this here. Of course, the sort of library or technology that we're using is a very big part of this. But, you know, I think this could lead into further discussions about whether we should be creating a library of common plots that we want to use, you know, a standard best practice for sort of making charts interactive, which is obviously something that we want to do. And I think, you know, maybe this even sort of helps cement the idea that we do want to hire someone that's specifically hired for transforming the messages of the work that we're doing into graphics, which I've said this a couple of times already in the past week or so. This is what we're doing. This is what it's all about. You know, it's fantastic that we've got, you know, this smart group of people here, but if we're not communicating clearly what we're doing to the public, then, well, we may as well not do what we're doing. So yeah, I don't know where to begin on this conversation. Unfortunately, Mauro has been able to pull these ideas together. Yeah, I think the biggest challenge is trying to get everyone on the same page and really making the process of generating new graphics more efficient, or if not more efficient, then we get someone that's an expert and that wants to help us make our messages clearer through graphical displays.
Thanks, Claire. I really like that, how you connected the plotting tools to communicating, because that is, you know, visualizations are probably the most powerful tool to communicating and to understanding data first. So understanding what we have, what we want to communicate, and then communicate it. Do we have any questions, any comments here? Anyone who would like to say, you know, which tools you have been using, and or what challenges you have been facing in terms of plotting?
Maybe I can comment like very quickly, like just a few minutes. So I have been using like both of Gplot and the JavaScript based libraries as well, but most of my work is like transforming from old one to new interactive one. When it comes to like like which library to use. In my opinion, let's say if we have printed reports or a PDF, then ggplot would be the best library to go with because of its like a flexibility to like have like different aspects, like you can modify the ggplot to like achieve like almost any plot and it would be like a print ready. But with that one, there are still some limitation when we go from like a printed or PDF version to, let's say, the book down version, or like we want to send it like as a link on the website, then it's like just a static chart. So most of the work I have been doing, it's in the hycharter library, which I would cover in the next session in the detail. But just to give like a brief idea, like let's say if we take like a ggplot, then it's like just a first layer. But when we use like a JavaScript based libraries, then we have like a 3 layers. So first layer is like the plot and important details on that specific area. The second layer would be on the hover, we can add more information. And the third layer would be like a, let's say we have limited space in the report and we are showing the chart, but we still want a user to explore more about like details about like how or why about that specific chart. Then the third layer is like a click event. So user can click on like any specific point on the chart, and with that point we can generate like a completely new chart. So with the JavaScript that would be possible, but with ggplot it will still stay in the first layer. So I will discuss this one in the like next session in detail.
Thank you. Anyone else would like to make comments or address some of those two questions I suggested? The tools you use, challenges you face?
Yeah, thanks. I think Pranav, that was a great point as to really defining what we want to be creating. And as you've rightly mentioned, that we are going from what was previously something simple in a static chart to this level 2 and level 3. And if we're going to do that, yeah, we need to make some decisions or get some more expertise in the team for that.
Good. Well, if there is also the Google document that we are now used to record thoughts even after this meeting. So feel free to use that if, as we continue with this meetup, something pops up that you would like to share, and then I can go back to the document and work on that. So the rest of the meeting is going to be particularly focused on one of the many tools that we're going to address over the 2 meetups. Today, I would like to talk about ggplot and maybe try to explain why it's a good way to start. But before we do that, can I have a click on the Yes Participants button if you have used ggplot 2 already, ever? Good. Thank you. More or less to have an idea of how deep we should cover this topic. In any case, we don't have a lot of time, so all I'm going to do is to give the basic recipe for a ggplot and also acknowledging that most people in this meetup today already used it, and maybe we don't need to get very deeply. But then it is interesting to consider that even in such a small sample of people like we are now in this meeting, most of us have used ggplot 2, and that is probably one good argument in favor of ggplot 2 as a place to start, which means that if we already have that background knowledge, it is probably like a very good beginning, and in most cases probably is maybe the only tool that you need, because then anything beyond that could be added on top of a ggplot by someone who is dedicated to visualization. So that's something to probably an idea to probably revisit at the end of the second meetup. So the very big picture of ggplot. So I also would like to kind of make a comment on the following. So ggplot 2 is the thesis actually came up from the PhD thesis of a very popular R package developer from Hadley Wickham. It has a lot of theory behind that he leverages to create to implement that theory in this package. But a lot of us, use the tool without even knowing much about the theory. So I would like to make a couple of comments about the underlying grammar behind ggplot2, because understanding what are the building blocks of this mental model will also help you understand how you can combine them in creative new ways. And also, I think it is important to consider that ggplot2 is one of the many packages in the tidyverse, which means that membership to the tidyverse means that this package shares the most common data structure in the tidyverse, which is the data frame. So the data frame flows from one package to the other in the tidyverse, and you can massage the data and do different things to it, including creating visualizations. And that is in contrast to other tools that may use vectors, may use lists, or whatever. But ggplot is part of the tidyverse. The tidyverse is centered around this idea of the data frame, which is, you can think of it as a spreadsheet, and therefore it plays really well with other packages. So this is one additional argument in favor to ggplot2. So not only it is a useful thing on itself, but it's also a great player in an ecosystem of tools that we are already using in our work. So the visualization is in this graph that I'm showing here that explains more or less how the data flows from importing it from somewhere to communicating it to our users, our readers. That shows what's the data science workflow, and visualizing the data is the core. It's the part where we understand what we have and we understand the message that we want to communicate. So key message there, the ggplot2 is one element of the tidyverse and plays well with the rest of the packages we are already familiar with. So the grammar is very basic. The grammar was built before ggplot2 existed. So Hadley Wickham built on top of that grammar, but that grammar did not have an implementation. I think it was written in 1976 by someone else. I don't remember his last name now. But it was kind of this theory about how you can express visually some concepts, but no one had implemented that in a tool. So, or at least as far as I know. So Hadley, what he did is, took those ideas, created a package for them. It's very simple. Basically, you take a data set, which here is represented as a spreadsheet, with columns and rows. Then you express what are the mappings to that data frame, which is, well, what column am I going to map to the x-axis and which column am I going to map to the y-axis. And then there is other mappings that you can use. You can also map one column to a third dimension other than x and y. You can map it to a color, or you can map it to a size, or you can map it to a shape, right? So those are mappings. So you have the data, and then you have a geometric representation of that data. There could be a point, it could be a line, it could be a box plot. So those are geometric representations of the data. So you have the data, you have the geometric representation, you have the mappings, and you put all that together into a coordinate system. The one that we are more familiar with is two-dimensional, x and y, but there is also, say, a polar system if you need to plot things in a radius. So when you put those things together, you already have a plot. One of the beauties of ggplot2 is that a lot of the things that it needs to create a plot happen just by default. So really all you need to do to start with a plot is this very basic template. You're surely, if you use ggplot2, you will recognize these elements. Basically, you need to pass the data, which more commonly you pass it to this function that creates the basic ggplot. The function is called ggplot, and then you pass a data set to it. Then you have to tell which geometric representation you want for that data. So this is a geom function that has different names. It could be a geom point if you want to plot points. It could be a geom line if you want to plot a line, and so on and so forth. And then these mappings that I was telling you about, which is how one column is going to end up on the x-axis or the y-axis, or on the color, or on the shape, or on the size, or whatever other mappings there are. So for a more concrete example, we can have a look at this particular plot. For example, what is the data that we are using? Well, here I'm using the data set Gapminder. I pass it here to the function ggplot, and I use explicitly the argument data, although I could remove it. The geom that I'm using, so I want to represent the data with a box plot. So I'm using the geom box plot that is available in ggplot2. And the mappings are passed to the function AES. AES is short for aesthetics. So basically you have to say how those mappings are going to end up in some aesthetic component of your plot. So here it's a very simple set of mappings. I'm only using X, which I'm mapping to year, and the axis Y I'm mapping to life expectancy. So life expectancy and year are two columns in the data frame Gapminder, and I'm representing those with a box plot. And this is what you get. So for in this case, for each of the years in the data set, I get a box plot, which is what you expect. So once again, going back, so this is the building block of a ggplot2. So if you understand this, all you need to know is to basically look up what's the geom that most closely looks like what you want. Stick the name of that function there, and the plot will change for you. There's a lot more you can do, and a lot more customizations that you can do, but with this, you get a long way down the road. So next, I would like to go to rstudio.cloud project, and while you click there and you create a copy of your plot, I am going to quickly go to two links that I think is very important. One is the ggplot2 website, and I encourage you to visit the reference section. The reference section has all the functions listed there, but something that I feel is very useful is a little plot of what the different geoms do. So you don't need to memorize anything really, you just need to come to this website and see, okay, the plot that I want to do looks more or less like this, like a box. So, okay, it's gonna be the geom box plot. And then you can click there and learn more about that function. So that's the one place I wanted to mention. And then there is a couple of other places that are really useful. Also in the home page of ggplot2, if you scroll down very quickly, you will see the cheat sheet, which in the beginning is really handy to have, I mean, maybe printed or in a PDF that you can visit quickly, because it explains basically, what we're discussing right now in a very clear way. So I think that until you develop a vocabulary for ggplot2, having this at hand can help you work very quickly, as opposed to spending time looking things up. And finally, as I said before, ggplot2 is built on top of grammar, so it has a very strong theoretical foundation. And the best place to learn about that, if you are interested, is the book. The book is, it was not free, but version 1 and 2 were not free, but now I discovered that version 3, which is in progress, is already online. So I linked to the book here, and you can, I read this book, I think in edition 1 a long time ago. It was really insightful. And this is really something for not just getting a plot done, but also for understanding the grammar if you're interested. It's pretty cool. So if you really want to dig deep, and if you think you're going to be spending time making plots, maybe you would like one day or two dedicate to skimming this book. Okay, so finally, let's go to rstudio.cloud. I'm not aiming to achieve a real lot in this RStudio Cloud project. I just want to give you a little feel for. I mean, I now know that most of you already use ggplot2, so hopefully you can go through this quickly. The first thing I would like you to do is to collapse all chunks so that we can hide the solutions, and you can do that with pressing the key Alt and then O, the letter O. That will collapse everything. So if I press then Alt Shift O, it will expand them. So Alt O collapses them. So now I'm going to click on Setup. It says Run Me Packages. I expand that. So all I do is attach the Gapminder dataset and the tidyverse, which includes ggplot2. Let's make sure it's running. then I expand the data just to give you a little overview of what the data looks like. Here I selected the columns year, life expectancy, and GDP per capita, and then everything else, just to give you a gist for what this data set contains. As you can see, there is the year, how many years a person can expect to live in that year, and in which country and continent that people is, and a few other variables that are not relevant to this particular demonstration. So we could, like simulating an experiment or an exploration that we could do ourselves. We can probably start at, addressing the data with a couple of questions in mind that will direct our exploration. So we could think of, for example, okay, so what is the life expectancy through time? Has it increased through time? Yes or no? So my hypothesis is that yes, as science progresses, life expectancy gets higher. So that's my first hypothesis, that life expectancy increased with time. And my second hypothesis is also that life expectancy varies significantly across continents. So let's explore those two questions. So I expand the headline for life expectancy through time. And this is a chunk that I would like to run as well, share with you, and start kind of moving on from here. So here you will recognize the template that I mentioned before, where we have a ggplot and a data set, and then a geom and a bunch of mappings. Also know that you can produce the same plot with the mappings passed to the ggplot function. And this might be useful when you want to do many layers of a plot. So maybe here you want to have something else, right? Some other geom. But both geoms need exact same mapping. So instead of duplicating the mappings, you can pass them to the ggplot function. So what do you think? Think for yourself. Does this plot, for example, answer my first question and my second question? Can I say that life expectancy has increased through time? Yes, no, or what else should I explore here? Go ahead and make a little comment if you want to the group. So I'm going to share my thought here. It looks like there is an upward trend, but I don't have a lot of information about how variable that is. So I'm not very sure if the trend is significant or not, because I don't have a very good idea of the dispersion of this data. So I should probably explore a bit more. And how about the second question? Do I have any insight about what are the different trends by continent here? So here is a full data set, and it's not split by continent, so it's not a very useful visualization. So next, we can refine this plot using ggplot tools to understand better this dimension continent that is not captured yet in my mapping. So I have to map one new variable to that plot to understand what's happening with the different continents. So let's do that. So in this section, your challenge is to modify the last plot, which you can copy and paste, and then modify it to show the patterns by continent. So the solution is here. I'm gonna give you like a minute here to see where we get from there. So copy paste the code that you saw before and try to adapt it to have an understanding of how the data varies across continents. I'm going to start working slowly as a way to provide hints. So I paste the code. So if I run this, I should get the same code that I got before. But now I want to add a new mapping that let me see the different patterns across continents. So there is the continent variable, and I want to map that to the color of the points. So I can do that here, for example, and say color equals continent. So continent has to be a variable in the dataset, otherwise it won't work, right? So if I say something that doesn't exist and I try to plot it, I will get an error. So if I add this new dimension, now I'm plotting 3 dimensions. I have a 3-dimensional data plot, X, Y, and color. That color is now referenced here on the right. And I can see that, for example, Africa is here in red, also increasing life expectancy through time, but lower than, say, Europe, which seems to also be increasing, but kind of higher than Africa, for example. So there is more that I can do here. I can now answer 2, but but again, I don't have a lot of understanding of the variability of the data. I don't know how many data points there are and if that trend is significant or not. So I could continue to refine my plot a little bit. One thing we could use is to change the change the geometric representation of that data, to, instead of using the individual points, to use a linear model that represents and captures all the variation within a country and shows it through time. How we can do that? Well, we can do that by using a different geom, like the geom smooth, which creates regressions with different methods, and the method also comes, there's a default that comes with it, so you can try it now. So go ahead and take another minute to see if you can now plot and modify the last plot, and instead of plotting points, if you can plot a model with geom smooth. So I'm gonna give a minute, and halfway through the minute, I'm gonna start answering the solution myself as a way to give you a hint. So, okay, if I start with the plot that I had before, the Gplot, as we learned from the template, all we need to do is modify that template to use a different geom. So now the geom I wanted to use is geom smooth. So let's see if I just change that, what I get. Okay, so here I have an entire line that captures the variability. So the gray area captures the variability, right? And the blue line captures the general trend. So the general trend is strongly upward. The variability is narrow enough that I'm quite confident that that line, if that line could fit within the uncertainty horizontally, then I would think that I need to explore more to know if that trend is significant or not. But here, it's clear that the trend is upward. I could not move the line inside to get horizontal within the gray area. So overall, the trend is it looks like strongly significant. Overall, the world has increased in the life expectancy, and I could also add the color. I know actually, modify this plot. Yeah, let's see, color equals continent. So interestingly, if I plot by continent, now that line splits by continent, and now each line captures the trend by continent. So I now can kind of confidently see that there is variability even across continents, and because there is no overlap in the uncertainty in most cases, I can also see that the life expectancy for different countries have been different across continents and through time, but all of them have increased through time, which is super interesting. So that is, those two things hopefully show what you can do with Gplot 2. There is a little bit more here that I don't have time to address, because we have now, we need to end to start the Taylor's meeting. But yeah, with that, I hope you now understand how the template that Gplot 2 provides can help you create different kinds of plots to communicate your data, to understand your data first and communicate it to your users. I encourage you to leave your questions or comments in the document. And that's all we have time just to say. But before we end, do we have anything like burning that you would like to share here? Okay. Well, the takeaway is, again, that little template that I told you about and the few links that I shared that should let you learn more about Gplot 2. So thank you very much. And I'm looking forward to the next ds-incubator where Pranav is going to talk about more sophisticated tools.
Thanks, Mauro.
Bye-bye.
Ciao.